Hello everyone, this is Jaganathan from ECE department at Sri Venkateswara College of Engineering and Technology. So this is an internship which is provided by MICROOVEN Information Technologies, where I have built a project named as microwave oven simulation using the PIC microcontroller. So first we are going to see about what is a microwave oven, requirements of a project, EMERTXE, microcontroller and microprocessor, PicSimlab software, timers, matrix keypad, ISR, CLCD interface and switches. First, what is a microwave oven? Microwave oven is a kitchen appliance that heats and cooks food using a microwave radiation. Basically, it consists of 4 modes, which is micro mode, grill mode, convection mode and a start mode. In micro mode, this mode is used to cook food in a traditional way. It uses a maximum power of up to 900 watts. In this, the maximum time that you can set for cooking is about 60 minutes. Micro mode is best for reheating food, cooking vegetables and simple meals. Next is a grill mode. Grill mode is uses a heating element to brown and crisp food. Grill mode is suitable for grilling meats, fish and toasting bread. Third is the convection mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After preheating is done, the user can set the time as per the requirements. Convection mode is ideal for baking cakes, cookies and roasting meats. So these are the requirements of a project. These are the requirements of a project, which includes MPlabxIDE, whereas IDE means Integrated Development Environment, and X8 compiler, PicSimlab software, and PIC16F877A microcontroller. So next we are going to see about what is MPlabxIDE. MPlabxIDE is a version of C programming language specifically designed for programming embedded systems like microcontrollers, IoT devices, automotive systems, etc. Key features of embedded systems are hardware instructions, uses microcontroller specific code. It is used for real-time operations. Mainly it is a free formatted language and does not require any strongly typed language. It is very efficient and portable. So a typical code contains a documentation, a preprocessed statements, global declaration and the main code, where the local declarations, program statements and function calls, and last is the function body. Syntax of any code in MPlabxIDE must be in this format, which first contains a header file and a preprocessor directive, which is #include stdio.h, and the start of the program, which is int main, and comment, a statement, and last is the program termination, which is return 0. So these are the topics I have learned about MPlabxIDE during the internship. First, introduction to C, conditionals, loops, which is while loop, for loop, do while loop, etc. Operators such as arithmetic operators, logical operators, arrays, pointers, functions, strings, memory and storage classification. So we can see about embedded systems. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within a larger system. These systems can be programmable or have a fixed functionality. An embedded system is a specialized computing system designed to perform specific tasks within a larger system. Embedded systems are used in industrial machines, consumer electronics, agriculture, processing industries, automobiles, medical equipment, cameras, digital watches, mobile devices, household appliances, aeroplanes, etc. So basically embedded systems are divided into two types. One is based on the performance and functional requirements, other is based on the performance of the microcontroller. Based on its performance and functional requirements, it is divided into real-time embedded systems, networked embedded systems, mobile embedded systems, standalone embedded systems. Real-time embedded systems requires quick response. Network embedded systems are connected to a network, whereas mobile embedded systems are portable devices, which is like smartphones, GPSs, etc. And standalone embedded systems works independently, for example digital watches, MP3 players, etc. Based on the performance of microcontroller, it is divided into small scale, medium scale and sophisticated. So these are some of the applications where embedded systems are used, which includes manufacturing equipment, domestic appliances, audio-visual equipments like LCD TVs, gaming consoles, telecommunication equipment. Embedded systems are used in medical devices. It is used in cars and vehicles, which is like high-end cars like BMWs, motion sensors. So next we can see about microprocessor and microcontroller. Both microprocessor and microcontrollers are used in embedded systems, but they serve different purposes. Microprocessor consists of only CPU, whereas microcontroller contains a CPU, memory, input-output, all integrated into one chip. Microprocessor is used in personal computers, whereas microcontroller is used in embedded systems. Microprocessor uses an external bus to interface RAM, ROM, and other peripherals. On the other hand, microcontroller uses an internal controlling bus. Microprocessor is the brain of computing system. It processes data that requires external components, whereas microcontroller is a self-contained system with a CPU, RAM, ROM, and input-output peripherals integrated into a single chip. So here you can see it consists of a CPU with input, output, timers, RAM, ROM and serial interface, whereas in microcontroller it is all integrated into one chip. PicSimlab microcontroller. It is used in our project. It is an 8-bit microcontroller. It is a part of PIC16 series and is known for its versatility, low power consumption and easy programming. This microcontroller is capable that can do many tasks because it has a large enough programmable memory. This microcontroller consists of 40 pins and 33 paths of input-output. The 40 pins make it easier to use the peripherals as the functions are spread out over the pins. This makes it easier to decide what external devices to attach without worrying too much if there are enough pins to do the job. So this is the pin diagram, pin functions. It consists of 40 pins. Here in peripherals, it consists of analog to digital converter, timers, buzzer, LEDs, digital keypad, matrix keypad, CLCDs, GPIO and EEPROM, a temperature sensor. So for using PIC16F8778 microcontroller, we use a software which is a PicSimlab. PicSimlab means Programmable IC Simulator Lab. PicSimlab is a real-time emulator of development boards with integrated MPlabxIDE. It supports some PicSim microcontrollers and some similar microcontrollers. As the purpose of the PicSimlab is to emulate real hardware, it does not have any source code editing support. For code editing and debugging, the same tools are used for real board should be used with the PicSimlab, such as MPlabxIDE or Arduino IDE. So this is the microcontroller PIC16F8778 we have used in our project MICROOVEN. The peripherals of this microcontroller is LEDs, tactile switches. This is LEDs, tactile switches, CLCDs, matrix keypad, timers, and a fan. So basically, an LED is a semiconductor device that emits light and an electric current passes through it. In embedded systems, LEDs are commonly used for indicators, status signals and debugging. It is the simplest device used in most of the embedded applications as feedbacks. It works just like a diode. It is low energy consumption, longer life, smaller in size, faster switching make it displays and many more. So in PicSimlab, the LEDs are connected to port D and port B. Both are 8-bit and are controlled by a corresponding resistor named as tris B and tris D. Totally there are 18 LEDs in the PicSim. So next is a tactile switch. A tactile switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and the time in our project. This switch will produce a bouncing effect when the switch is pressed. This is a tactile switch. It consists of two circuits, which is a pull down circuit and a pull up circuit. Next is a matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when no number of user inputs are required and still want to save some controller input-output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. So next is interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. It goes back the processing where it got interrupted. So there are basic types of interrupts are hardware interrupt, software interrupt, maskable or non-maskable interrupts. So in pooling is a technique where the microcontroller continuously checks a peripheral or input pin to detect changes or events. Unlike interrupt, pooling is not event driven but rather a continuous checking process. So timers is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or external clock. It has many applications such as measuring the time and generating delays. Timer or counter is a software designed to count the time interval between the events. Resolution, which is also called register width. In our project, timers are used to check the timing of the food. It checks the timing of the cooking time of the food. Last is the ISR. ISR refers to interrupt service routine. An interrupt service routine is a special function that executes automatically when an interrupt occurs. It temporarily pauses the main program, handles the interrupt event, and then resumes the normal execution. An ISR is a software routine that hardware involves in response to an interrupt. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable, and at last it returns from the interrupt. So now we can see about the demo of our project. So this is a main code for a MICROOVEN project. It consists of a main file and source file, C source file, header file, clcd.h, another header file where we have declared void power on screen, void clear screen, display menu screen, set time, time display, set temperature, heat food, and timers.c file, isr.c file, it is clcd.c, at last matrix keypad.h. So in main.c file, first you have declared a CLCD and then fan. We have configured CLCD, fan, timers and buzzer, which we are used in our project. In while main, first the menu screen should be displayed. If key 1 is pressed, micro mode should be displayed. If key 2 is pressed, grill mode should be displayed. If key 3 is pressed, convection mode, and if key 4 is pressed, start mode. So in MICROOVEN.c, we have declared a void set time and time display. Atlas void set temperature. So let me clean and build. So the build is successful. Let me run the code in PicSimlab. Let me load the HEX file. So here is the 4 modes. First mode is micro, power 900 watts. I am setting the time of 30 seconds. Enter. So here you can see, if I press 5 it should pause, and if I press 6 it will stop. If I press 4 it will resume. It is paused. It is resuming. If I press 6 it will stop. So second mode is grill mode, which is same as micro mode. Let me set the time 30 seconds. So if I press 5 it will pause. If I press 4 it will resume. So third is the convection mode. First we want to preheat our micro oven. So let me enter 3 minutes. And fourth mode is start mode. Thank you.